Hello, I'm Francesco Oliva and I'm an electronics engineer, with interests in Internet of Things, machine learning and computer vision. I took this specialization course on Coursera because I have experimented in the past with Raspberry Pi, so I was curious to switch to another single board computer. As you can see in the picture, the surveillance system is composed, other than the Dragon board and its adapter, by a 1.3 megapixel USB webcam with night light and a passive infrared sensor. The webcam is easily detected by the Dragon board, while for the infrared sensor you must connect it to its GPIO pins using 3 male to female jumper cables. Regarding power consumption, in my project I have considered to plug my IoT system in the wall, the regular domestic power supply. So developing my program, I have not considered to reduce power consumption by putting the processor in sleep mode as much as possible, minimizing communication outside of the device, or looking for every unnecessary amount of current. I created then Python program which utilized the USB webcam for face recognition, picture saving, display a live video feed from the webcam, together with the passive infrared sensor for motion detection, with the purpose to recreate all the basic functions of a surveillance system. Looking at the program, first of all, I loaded all modules needed by my application, like the OpenCV library, the modules that use SMTP to send email, the module to manage the thread-based parallelism, and finally the modules needed to make and manage a simple HTTP web server. I have a main function in which I call one function for the PIR sensor called motion_detection, one function for the face identification algorithm called face_detection, and the handler class for the webcam server called camHandler. The motion and face detection functions are managed as concurrent threads in background while the server is running. While for the motion detection function I have only take care to read the pin of interest, the face detection instead is a bit more complex. We need to call the OpenCV function for HAR feature-based cascade classifiers named faceCascade.detect multiscale that will use the pre-trained classifier for face stored inside a XML file. If faces are found, it will be drawn at the positions of detected faces a rectangle. Then the image will be sent by email. The function for email alert sending is called send_mail. It will use the MIME image and MIME multipart packages for sending image and multipart emails, other than the smtlib.smtp function to manage the SMTP protocol.
So this is my prototype. Now I will test my system. I will launch my script. Here I print for debugging purpose. You see, I received a message on my cell phone. With the face detected. If you go on the local address, you can see the live feed. Here.
about the problem that I faced during my project. So, if you want to avoid false face detection, you have to set correctly the parameter of the detect multiscale, OpenCV function, estimating the correct ones after lot of testing at runtime. Regarding multithreading, if you want to use the server together with the motion and face detection function that run concurrently, I have to use multithreading, otherwise the program would stuck forever on the server call without ever execute the motion or face detection functions. I flashed the Dragon board with a Linux Debian-based operating system, so I did not consider for this project all the material about Android. I have used the PIR sensor like explained in Course 3, Sensing and Actuation from Devices. I didn't use Linphone from Course 4, Communication Technologies. I used OpenCV and Face Detection Algorithm from Course 5, Multimedia Technologies. This project can be improved, for example setting up a LAMP, Linux, Apache, MySQL, PHP, stack on the Dragon board and configure it to work as a web server. Then we could use the SQL database to store informations about images and motion detection alerts and load them on a PHP web page on the server. Or it could be created a web page in which the user may prefer to switch on or off one of motion or face detection. Obviously, another improvement would be to make the system solar powered. This is an expensive choice but necessary if you need a self-sustained power source in outdoor environments and there is no possibility to plug your station to a household power supply system. Based on how much power your system consumes, you have to buy one or more solar panels, a solar power controller, a battery, LiPo or lead acid, and a power inverter as explained in the capstone video lessons of the course. Checking on internet spending should exceed at least $150.